Dr. Lane. This is my reassessment for forces and circular motion. I redid the assessment that we took in class of the ball on a string being whipped around with centripetal force. And it asks for the tension of the string whenever it's at the very top. And so I drew my free body diagram, and the force is acting on that string, since it is a string, and everything, it's always from that center of this mass is pulling toward the middle. So the rotational force is combined with gravity, pulling that weight down. So I already know gravity, I already know the mass, and I already know the gravity. So I need to find the rotational force, which I use this one, this radial acceleration or tangential speed, which is v squared over r, obviously, and these are all givens. The velocity is 2.5 meters per second over the radius of said circle, which is just the length of the string, and that turns out to be 15.625. However, it's looking for the rotational force. So since I have this, F equals ma, or rotational force equals mass times radial acceleration, so I plug this in to find my rotational force, which is the other force amongst gravity working on this tension string. And so I plug all that in, and then I get it, and then I write that for the tension of the string, the forces of that are Fr minus mg. And since it's a string, the tension, and my camera's out of focus. Okay, that's better. And that's going to make it to where the rotational force is minus the gravity times the weight of the ball, which gives me the tension of that string. Then for the second part, it asks for the acceleration of the mass whenever it's in position B, which is to the side here. And with that, it says if tension remains constant. So the forces on this ball are just gravity in the downward direction, and then the tension of this string, which will be going away from the ball toward the center. And so the way I did this was I just made it a right triangle and made it to where a squared plus b squared equals c squared, or vice versa. And so I just combined my forces, the ones in the x and the y direction, and I made it to where, put that in the radical, it came out to 18.44 meters per second squared, but that's just a scalar. Like, I don't have a direction. And so obviously whenever the ball is coming back around in this direction, I have to find a direction. So I have my opposite and I have my adjacent. And so I wanted to find this angle to see in which direction I'm going. So I did inverse tangent of opposite over adjacent, and or y over x. And that gives me 32.1 degrees below the negative x-axis going this way. So I have my magnitude and I have my direction, and that's where it's going to be going. And whenever I looked at my King of the One quiz here, I should have known, or I do now, I did not know that there was a difference between the tangential speed, or whenever it uses omega, which is asking for the velocity, and the tangential speed is in meters per second, and omega is in radians per second. So that's definitely something new, and I found out a lot of the stuff I did wrong. But that's it. All right, thank you. Bye.